Okay, day 8. We get the input, which is a bunch of antennas. I was struggling reading the instructions today, and looking at Reddit, seems other people were memeing on that. So yeah, but once you understand the instructions, it's simple. So each number or letter is an antenna, and we just need to find each in one group, and then if they are on a line, we just add a antinode here and an antinode there, and it doesn't matter if there's already an antenna there, it's still an antinode there. So we get the data, then we want to get that into a grid. So a record quick. That should be lines, and map each line, chars, collect. And then we need to check if these frequencies or the antinodes is outside. So we also need the size of the grid. So the number of rows will be length, and the number of columns will be like that, because they're all the same. And then we want to get every character that is not a dot. So we shadow the data again, and then each thing will be a position and a character. So this would be data, iterate over it, enumerate, so we get the ID, and then we can flat map that. So we get the row and the row ID and the row as a row. Then we just iterate over that, enumerate that, so we get the ID as well, and then map, and then we get the column and the char in a tuple, of course. And then what we want to return is a tuple of the row and column as a vector. And I found a math library for this, which is called CG Math. So I'll add that, and later we're gonna need iter tools as well. So the position will be a vector2 new, and then we want the row and column, and we also want the character. And am I having the correct amount? Yes. Then we need to filter out all that are not dot. So for each node should not be equal to dot, and then we just collect it, and that needs to be the value. And I think it's complaining about move, so here we need to move it. Just do what the compiler says, the Rust way. So now we have a vec of position and character. Now we want to group them by character. So we could create a hash map and then just add the character as a key and the vector as a value. So we'll do that using the fold iterator. So again, we'll shadow data, iterate over data, fold it, and initially we want to start with an empty hash map. And then here we have the hash map, and then we have the node, and then we want to add the node to the hash map on the character as a key. So the hash map entry and the character, if that does not exist, we should create a new vec. So or insert with new. That should return a vec. It takes a function that creates it, and then we need to push the position, and then also return the hash map here. Right, and then we do not care about the character, so we're just gonna get rid of that. So just convert it back to a vec, which will be a vec of vecs. So would be data values collect. So now it's a vec out of groups, and each group is a list of positions. And so then we just want to loop through the groups and then the combinations. So between each A, we want to add anti-nodes where it fits. So for each group in data, iterate over that, and then for each, and then in group, iter, and then we have something called tuple combinations. And so tuple combinations is the same as doing combinations too, but then mapping that to a tuple instead. So it just saves us a bit of time. And then we want to have a set of all of the anti-nodes. And then in the end, want to print that. So for each combination, we just want to get the difference and then add that. So if we have the delta b minus a, then that would be from a to b. So then the one new antinode would be if we go A minus delta would be 1, and then we would also want B plus delta, and then in the end we can just say that we want to retain only the ones that are in inside the grid. So only if node X, and by the way, X here, it's actually Y, but it doesn't matter. We don't care because X is the row and Y is the column, but for this puzzle it doesn't matter. So X has to be bigger or equal to 0, and Y has to be bigger and equal to 0, and X has to be less than N, and Y has to be less than M. And then we can run it, and it doesn't print. We crash. Oh, right. Because when we collect this, the vector 2 needs to be of I size, so we can use negative numbers. And all right, 359. That was correct. And then for part 2, it's equally simple. Just should continue in a straight line, but also the actual nodes are like each tower is a frequency antinode also. So we still do the delta, but then we can just move from A and in the opposite direction, and B in that direction. So start on A and then while, and we'll just copy that. While the node is okay, we add it to the antinode, and then we need to move it in delta direction, and then we just copy that and say delta is equal to negative delta, so in the other opposite direction, and we don't need that. Now the actual, like if we run this, we get the correct 1293, so it's the correct result, but here really what you want to do is that you want to let delta be delta and then scale down by the greatest common divisor of delta x and delta y. But we don't have to do that because the puzzle input, at least for me, and on Reddit it seems for other people also, this always is 1. So we don't have to do that. Yes, and yeah, this is very fast. Okay, now it So build it release time, and what is the target release? So yeah, very fast.